Welcome to Maths Clinic series. In this video, we are looking at the laws of logarithms. And this is video number 3 of the series of logarithms. And I told you earlier on in the video number 1 that we are going to look at 3 keys that will guide you in answering questions involving logarithms. And the second key is the law. So we're going to look at 4 different laws of logarithms. By the end of this video, you should be able to identify the laws of logarithms and apply them in answering simple questions. Law number 1. If we have log base ax or log s base a, and you are adding it to another log of the same base, the most important thing is that they have the same base, and we are doing addition, then according to the first law, we'll maintain the base and multiply the exponents. That is the first law of logarithm. Example, if I have log base 2 4 plus log base 2 5, I can easily write it as log base 2 4 times 5. And the reverse is also true. The reverse is also true because if I have log base 2, let's say 12, I can write this as log base 2 6 times 2, which can be written as log base 2 6 plus log base 2 2. So we can do the reverse. So if we have a multiplication, it can be expanded as addition, and if you have addition, you can compress it as multiplication. So we have another example. If I have log base 5 2 plus log base 5 x minus 1, since the bases are the same, I can easily maintain the base and multiply the logs by saying 2 times x minus 1. Again, if I have log base 7 2 on 3 plus log base 7 3, if the bases are the same, we can multiply the logs, and that becomes log base 7 2. Alright, now let's look at law number 2. The law number 2 says that if I have log base ax minus log base ay, I will just maintain the base and divide the logs. And take note of this: the first goes up, the second goes down. Interchanging them will give you an error. If I have log base 3 10 minus log base 3 5, I can simplify this and write log base 3 10 on 5. Per this very law, in future, if I give you 2 exponents, or let me just say log base 2, let's say 27 divided by 3, and it's a question that I want to simplify, I could simplify this by writing log base 2 27 minus log base 2 3. Since it's division, I can expand it as subtraction. Now let's see another example. Or before the example comes, this is a warning. This is a very good warning, that if we are saying log base 3 10 minus log base 3 5, sometimes you may forget the law and you'll be tempted to write as log base 3 10 divided by log base 3 5, and that is not correct. Alright, it should be log base 3 10 divided by 5 without the log. So the log is maintained, then we divide the numbers, not to divide the whole log over the whole log. That is wrong. So if I have log base 2 this minus log base 2 that, I can easily write it as log base 2 x squared minus 1, or divided by that. And I can simplify that to get log base 2 x minus 1, because x squared minus 1 can be written in the difference of 2 squares as 1 square. It's the same thing, which of course can be written as x minus 1 x plus 1. and so one of the s plus 1 here will cancel this, and then we are left with that. Okay. Law number 3. Now with the law number 3, if I have log base a x to an exponent of n, then we are saying that the exponent move backwards to multiply the log, and that will give us n log base a x. So in future, when you are solving questions and you come across log base 3 5 to the power 2, you can easily write it as log base 2 times log base 3 5. Again, this can also be written as that, and that is how the third law works. All right, good. So if I start a question and the question comes like log base 2 x squared, then quickly I must know that I'm going to write 2 log base 2x. That is what we are trying to say here. Then the last law, that's law number 4, which is called change of base, the only law with the name change of base. Now I want you to pause the video, use your calculator to figure out the value for log base 3 7. You see that the answer will come as 1.771243749. Right, so what we are trying to say here is that if I pick the log, this very log, and I change the base from base 3 to any base, let's say base 2, and I keep the 7 at the numerator and say log base 2 7 divided by log base 2 3, that is the 3 here will come as such and the 7 here will come up, and I change the base and I divide these two logs, the value will be the same as this value. That is what we are saying. So you can give it a try and see. If somebody decides to make it log base 18 7 on 3, we'll still get the same answer. Again, if I have, let's say, or let's say in general, if I have log base a x and I want to change the base a to any base, then I must change the base, all right, and then keep the s numerator and keep the a as a denominator. In that case, the value over here will be the same as the value I'll get for this one. You can try this example and see. Give yourself the value of log base 2 5 on calculator, and then also do log base 10 5 divided by log base 10 2. You get the same answer as this one, and that is what the law is all about, and we call it change of base. We'll be applying it in solving questions in future. So the same value here can be the same as this. So far as the 5 and the 2 remain here, 5 and 2, we can change it to any base, and when I divide, I'll get the same answer. Finally, we can also say that this can be equal to that and can be equal to that. The 4 and the 6 are the same here, 4 and 6. I will change it to any base, I will divide and get the same result. Or here too, I can change to base root of 5. Since 26 remains and 4 remains here, it will be the same. But the caution is that if I let the 4 go up and the 26 comes down, the result will not be the same. So the number here goes up and the base here goes down, and that will make this law applicable. So with this, we come to the end of the video number 3. That is the laws of logarithm. The next video, we're going to look at the properties of logarithm. We are going to apply these laws in solving series of questions when we come to logarithmic equations. Alright. Or we come to solving general questions in log. With this, we come to the end of video number 3. Thanks so much for watching.